Let's finish up this section on ray diagrams for converging lenses. We just saw the properties of the image when the object was placed further than the focal point. In this case, we're going to look at what happens when the object distance P is less than the focal length. So the object is going to be placed somewhere between the lens and the focal point. These ray diagrams are a little bit harder to draw, but we just need to follow the same exact rules. So let me go back and put my three rays parallel on one side, focal point on the other side, going through the center and straight through, focal point on the left side, and parallel on the other side. So let's take a look at these rays. Ray number 1 here is parallel to the axis, emerging from the object, and then it's going to refract through the focal point on the other side. Ray number 2 goes straight through the center, keeps going, the blue ray here. Ray number 3 is a little bit harder to draw because we need to go on the focal point on the left side before we can emerge parallel on the other side. But we are over here, right? So how can we go through the focal point when the focal point is over here? So we have to appear to come from the focal point. What we do is we draw a line from the focal point and then it hits our object so that the ray of light is still emerging from the object, but it's emerging from the direction of that focal point here. And then as soon as it hits that lens, it's going to emerge parallel. So it's still following the exact same rule of focal on the left side, parallel on the right side. The only difference is that since the focal point's not here, we can't actually go through it like this. We have to appear to come from that focal point. Now let's look at the characteristics of our image that is formed. Well, the first thing that we notice is that the rays do not intersect, they diverge. So that means that a virtual image is going to be formed because we have to trace those rays back and see where they intersect right here. That means that virtual image will be formed right here. We cannot capture this image on a screen. We can also see that the image is upright and that it is larger than the object. So those are their characteristics. It doesn't matter where you put the object between the lens and the focal point, it will always have these characteristics. A great application of this is your magnifying glass. When you use a magnifying glass, usually put it very close to the object. So your object is here. You put the lens very close to it, and then your eye is going to be on the other side. It's going to be over here. And since the image cannot be formed on a screen, you have to be here and you have to look through the lens. And when you look through that lens, then you see the magnified image. So that's a really good application. Let's look at one more question to finish up this section. So in this case, based on this ray diagram and the properties of the image formed here, this is the object here, this is the image, we need to be able to tell exactly where is the object placed. So what we notice is that the image formed is real because the rays are intersecting. So we know that this is not the case here. The object distance is not smaller than the focal length. That would be like the magnifying glass forming the virtual image. So it turns out that the object distance P is going to be larger than the focal length. We saw that, let's say the focal length is over here. And so 2 times the focal length would be here. So the focal point is here. This would be 2f here. We saw that when the object is between f and 2f, that the real image is going to be bigger than the object. So our object is larger than the focal length, but actually smaller than 2 times the focal length. That's it for this section. In the next section, we will start looking at ray diagrams for diverging lenses.